Welcome to today's lesson. We are going to look at definition of force, and this refers to push or a pull, and this is due to interaction between the bodies. We have that the SI unit of force is Newton. Note the symbol is capital N. Force has both magnitude, and when we talk of magnitude, we refer to the size. So we can as well say that force has both size and magnitude, and therefore it is a vector quantity. Force is represented by a straight line and an arrow. The length of this line from here to here represents the magnitude, while the arrowhead represents the direction of the force. Then we move to types of force. We have the first one, gravitational force, and this is the force of attraction between any two bodies. We can give an example of attraction between Earth and Moon, attraction between two human beings. Any two bodies that are not in contact, there is force of attraction. Then gravitational force is non-contact because the two bodies are not in contact. Therefore, we have that it is a non-contact force. Then, have you ever asked yourself why when you throw objects upward, they always come down? Or when you are seated under a mango tree, you find the mango falling and not rising up? The answer is here. This is because of gravitational force of the earth. And this is the attraction on bodies towards the center of the earth. You find that whenever you have an object that is on the surface of the earth, it is always attracted towards the center of the earth. Factors affecting gravitational force. One, we have the masses of the object. We say that when you have that the masses are larger, then the force of gravitational force is greater, and vice versa. When it is smaller, then the force is weaker. Then the second factor is the distance of separation between the two bodies. When the distance is longer, it is weaker, and when the distance is, or when the objects are closer, then we have a stronger gravitational force. We move to another type. We have centripetal force, and this is the force that maintains a body to move in a circular path. The word circular comes from the word circle. So it's like the body is moving in this circular path. This force that maintains this body to follow this path is what we call the centripetal force. And it is always directed towards the center of the path. Then we have example of situation in which centripetal force acts, and this one includes when you are wheeling a stone tied to a string. Then we move to magnetic force, and this is the force of attraction due to a magnet. It is a non-contact force, and here we need to know when do we have attraction and when do we have repulsion. And for us to understand that, I want us to look at this diagram. Whenever we have south and north, there is attraction. Whenever we have a magnet and a magnetic material, there is attraction. But when we have a south and a south, or a north and a north, there is repulsion. So we have attraction when we have unlike poles. When you have south and north, these are unlike, they are not similar. So we have attraction. We also have attraction when we have a magnet and a magnetic material, like in our last case here. But repulsion occurs only when we have like poles. Like means that they are similar. South and south, north and north, they are similar, and therefore there is repulsion. Then we move to another type. We have upthrust. In this one, whenever we put an object inside a fluid, that is, you can put in water or gases, you find that there is always that upward push. And then you ask yourself, what makes this object to weigh less? It is because of that upthrust. This one is an upward force acting on object immersed in a fluid. It is also defined as the apparent loss in weight, because when you weigh that object that is already immersed in fluid, it weighs less. It's like it has lost some weight. And if you look at the diagram that we have here, This is what we are calling the updraft force. You have the object that is immersed in a fluid, and then you have an upward push that is making this object to weigh less. So mathematically we say that upthrust is equals to weight of body in air minus weight of body in a fluid. So we can look at an example. We have a body that is weighing 200 Newton in air and 180 Newton when submerged in water. Calculate the upthrust acting on the body. Whenever we have calculations, we always start with the formula. This is our formula. Then after putting the formula, we substitute our values. Weight of body in air is 200 Newton. Put that. And then weight of body in fluid is 180. That is what we have here. Then subtract. When you subtract, you get 20 Newton. So in this example, the upthrust is 20 Newton. Now we have the examples of situations in which we have upthrust. Is that one, we have balloons rising, swimmers and boats floating, and bodies weighing less when they are immersed in a fluid. Then we move to frictional force, and this one we say that it is the force that opposes relative motion. You have two bodies that are in contact. You are trying to move one, and then you find that that motion is prevented. That is what we call the frictional force. When we have that force of opposition in fluids, we call it viscous drag, or friction force in fluids, we call it viscous drag or viscosity. This one is a contact force. Remember, we are saying that the two surfaces are in contact and they act in opposite direction. You can see in our diagram. You are trying to move this box towards this direction, but you find that there is another force that is resisting, that is preventing. That is what we call the frictional force. Then we move to disadvantages of frictional force. One, it causes wear and tear. When you have the machine and we have the moving parts of the machine, you find that as you continue using the machine, the moving parts are destroyed. They are destroyed because of the frictional force, because it causes wear and tear. Then it prevents motion. It produces unwanted heat, or it produces unwanted sound. You can even look at a simple machine like wheelbarrow. When you are working with it at home, you always find that if it is not oiled or if it is not maintained well, as you move it will make unnecessary noise. And if you touch that moving part, you find that it is hot. And finally, you will find that that part will get destroyed. Now, how do we reduce this to avoid these disadvantages? One, we minimize frictional force by oiling and greasing. That is why we keep on oiling our wheelbarrow, our bicycles. Then we have using rollers. When you want to move a very heavy object, it's advisable that you use rollers. This will help you to reduce friction. Then streamlining the body, making a body to be sharp or to be thinner towards the front so that it can be able to have less resistance. Then we have frictional force helps in, because we have seen the disadvantages. Do we have advantages? This is what we are going to look at. One, it helps us in writing. It helps us in braking when you want to stop a car, when you are walking. Have you ever tried to walk on a slippery ground? It is very difficult. You keep on falling because when the ground is too slippery, the friction force is less, and therefore walking is difficult. So for you to walk comfortably, you need a rough road. Then it helps us in erasing and lighting a matchstick and many others. So we move to another type. We have electrostatic force, and this is the force of attraction between any charged bodies. And when we have the charged bodies, we can have either positively charged or negatively charged. In other words, we are saying we have two types of electrical charges, positive or negative. And this force is a non-contact. The two charges are not in contact. Now, you can look at the diagram so that we can be able to know when do we have attraction. In our first case, we have a positively charged body, and the other one we have a negatively charged body. As you can see, there is attraction between them. But in the second case, we have a positive and a positive, but we have repulsion. Then the third one, we have negative and a negative, and we have repulsion. So attraction occurs between unlike, positive and negative, unlike charges, while repulsion occurs between like. Like means that they are similar. Therefore, we have similar here, positive and positive, and negative and negative. So in these two cases, we have repulsion. Then we move to electrostatic force. We give the examples of situations. We have a plastic ruler. When you rub it against your sweater or against your cloth, you find that it will attract small pieces of paper. When you rub, you create charges. And those charges are the ones that are responsible for the attraction of pieces of paper. Then we have another case. When you wipe your window rapidly, finally you find that it has attracted a lot of dust. This is because by wiping, you created some charges and you left some charges there. So those charges are the ones that are responsible for the attraction of dust. Then you realize that when you polish your school shoe rapidly and then you start walking, within a short distance you find that your shoe has attracted a lot of dust, and then you wonder why. This is because by rubbing, by polishing, you find that you have created some charges, and these charges again are the ones that are responsible for the attraction of dust. Have you ever noticed when you are removing a nylon cloth, there is that crackling sound, and sometimes you even see sparks, and that cloth sticks on your body? I'm sure you have experienced this. The reason as to why we have all this is because when you are removing your cloth, you are rubbing the cloth against your body, and therefore you are creating charges. Those charges are the ones that are responsible for the crackling sound, and it sticks on your body because there is that attraction. So we move to another type. We have action and reaction forces, and these ones are two forces that are opposite, but they are equal in magnitude. You can look at the diagram here. You have a box that is resting on the table. The weight is giving us action, and the reaction is provided by the table. That is why now this table is able to support the box. These two forces are contact, and they act in the opposite direction. Then we move to nuclear force. This is the force that binds protons and neutrons in atomic nucleus. As we are going to see, we have an atom. An atom has a nucleus at its center, and in that nucleus we have protons and neutrons. Protons are positively charged, but neutrons have no charge. Therefore, the force that keeps them together is what we are calling the nuclear force. This one is a contact force. Then we have tension. When we have the tension force, this one acts on stretched bodies. As you can see in the diagram, we have a spiral spring or a thread. Whenever you put some weight here, this spiral spring will be stretched, and therefore it will provide the tension. The tension will act in the opposite direction. We have weight acting downward, but the tension is acting upward. The same case applies to the second diagram here. The thread will provide the tension, while the weight is acting downward, the tension is acting upward. So this force is contact force, and as we have seen, it is acting on stretched bodies. Then we move to an assignment. If you look at this assignment, it is evaluating you on what we have just covered. It is important that you revise before you attempt. In calculations, we have said that you start with the formula, then substitute, and then ensure that you have indicated the correct SI unit. So thank you and welcome to the other lesson.